Okay, so basically they give you a problem with a rod that has a mass m and has a length L. So the first question asks, I don't know if you can see that, but alright. So basically the first question asks that what is the inertia about the center of the mass right there? Uh, so the way to do that is you can do the parallel axis theorem, where it is I at the end of the mass right here, the inertia right there, equals the I at the center of mass plus mr squared, and the r is the distance from here to there. So if we do that, we know the I at the the I at the end of the rod is ml squared over 3. That's just something you can remember. Equals I at the center of the mass plus mr squared, and the r from here to here is L over 2, because that's all L, so that's L over 2. So you substitute that for r, and you get ml squared over 4. So you just move that over here, you get ml squared over 3 minus ml squared over 4, you get I at the center of the mass. So that proves I at the center of mass is ml squared over 12, and that's what they want you to prove. Question B basically says, now there's a hoop around the rod. So it's a rod that's fixed inside a hoop. And what they want to know is the total inertia of the rod plus the hoop system. To find the total inertia, all you have to do is I total, equals inertia of the rod plus inertia of the hoop. We already found the inertia of the rod about the center of mass and the previous problem right here. So we just plug that in, m plus mr squared. That is the equation for inertia of the hoop. That is just something you have to remember. And r is, right here it says r equals L over 2. That's the radius of the hoop is L over 2. So you plug that back in, and you get I total, inertia of the system is ml squared over 3. And that answers questions B. And then C says, now there's a rope tied around the hoop, and it's left hanging. The rope is hanging, and there's a cat hanging from the string. So you can think of this as a pulley, I guess. And there's a rope hanging, which is tied around this pulley and is hanging, and there's a cat at the bottom of the string just hanging. And what they want to know for C is the tension in the string when the cat is hanging. So for that, we have to draw a free body diagram, because tension is a force and we need a free body diagram for that. So that's what I did over here. There's the pulley and the string, and the cat is just a block. So if you do the free body diagram for that, is mg down, and there's tension up on the string, and that's the same tension right here, because it's the same string. It's a massless string. There's no mass. There is a mass in the pulley. Okay, so but there's no mass in the string, so the tension is the same in top and bottom. So to find the tension in the string, we can do the summation of forces for the cat. So we do F equals ma, and the summation of forces is mg minus t. So mg down minus t up gives you the net force down. So mg minus t equals the net force ma, and we can't find ma. We can't find t because we don't have acceleration. So we got to find acceleration. So we move to this equation. Torque equals I alpha. We need this equation, so the reason we bring alpha into this is because we need acceleration. So if we have alpha, we can find acceleration. So what we do is torque equals, we know I of the system. We found that in B, which is ml squared over 3. And Yes, it's m all squared over 3. And alpha is just a over r right here, because a equals r alpha. So a over r is alpha. So a over r. So basically torque equals, right here, torque equals ml squared over 3 times a over r. But that doesn't help us much, so we bring in another equation. Torque equals force times distance. That's we learned that a long time ago. That's just like the simple equation. And the force is tension. That's the only force acting on the pulley is the tension. And the distance is the distance from where it's pulling to the axis of rotation. So in that case, there's a pulley, there's the strings coming down right here. So that's the tension right here. And this is the axis of rotation. So that's the distance. So it's tension times distance. So it will be tension times L over 2. So torque equals tension times L over 2. So now we can set these two equations together, because that equals torque and that is torque. So we can set these equations together and we'll get T L over 2 equals that junk right there. And we can replace R with L over 2, because the radius of the hoop is L over 2. So yeah. And when you do a bunch of algebra, cancels out, you do that, blah blah blah, you get TL over 2 equals 2MA over 3. And then you get A equals 3/4 T over M. So now we have A. If we have A, we can figure out tension. So you plug it back into the original equation. Mg minus T equals MA, right? So take that A right there, plug it right here, and you get Mg minus T equals 3/4 T, because the M's cancel out right here. M's cancel out, so you just left with 3/4 T. You bring the T over, you get Mg equals 3/4 T, and then you solve for T. T equals 4/7 Mg. So that is how you find tension. And then D asks you right here, determine the angular momentum of the rod hoop assembly. So for that is really easy, because we have acceleration, so angular acceleration is really easy. So all we do is alpha equals a over r. Alpha equals, and you plug in acceleration from previous problem right here. That's acceleration. You plug that into acceleration, and r is L over 2 again. But then we have to substitute t. We can't just leave t like this, because we have to we can't answer in terms of t, so we have to substitute t. But we already found tension in part B, so that's tension right there. So you have to plug that in for tension. When you do a bunch of algebra, m's cancels out, you do all that, and you're left with 6/7 G over L. That is alpha. Finally, right here, part E. Actually, it's not finally, there's still 2 more left. Part E asks you, determine the linear acceleration of the cat. So we can use that equation right here. Mg minus T equals Ma. And then we plug in T from our part B, that all the M's cancels out. And now you're left with G minus 4/7 G equals A. So A is 3/7 G. So that's really easy. And now finally we do, after descending a distance of h equals 5/11 5L over 3, the cat lets go of the string. At that instant, what is the angular momentum of the cat about point P? So basically what they're saying is, the cat is hanging off a string, right? And it starts accelerating down when you let go. So the cat keeps going down and down and down and down, and the pulleys see it spinning and spinning faster, because it's all tied up, the rope is tied around, so it keeps getting faster. But then at some distance, 5L over 3, the cat lets go. So they want to know what the angular momentum is in reference to that point right there. So that is the point in reference to what is the angular momentum. And we know the equation for angular momentum is L times R cross P. P is just momentum, linear momentum. So L equals R cross P, which equals R cross mv. And to find V, what is V? Well, V is just the final velocity, or the velocity right as the cat lets go of the string, right? Right as the cat lets go of the string, that's the velocity. To find the final velocity, what do? You use kinematics. So you use this. So you do Vf squared equals Vi squared plus 2AD. Remember, the A, you're using linear acceleration, not angular acceleration. We're doing kinematics and linear kinematics. So Vi is 0 because the cat starts from rest, right? The cat starts from rest and starts going faster with the string, and it lets go right about here somewhere. And then that's what we're trying to find, is the velocity right there. So, where is it? So yeah, so Vi goes to 0, and you plug in A. We found A already. We know D, they give us D. So you do a bunch of algebra and you get Vf equals square root of 10GL over 7. That's the final velocity. I can plug that back in right here, R cross mv. And you get L over 2, because that's R, is L over 2, times R, times M, times V. And you combine that and you get L equals, or angular momentum equals ml over 2 times square root of 10GL over 7. That's pretty much it.